Today we're going to talk about the ratio test. We have let sigma n equals 1 to infinity of a sub n be a series of non-zero terms. Number 1 says the series converges if the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n is less than 1. Number 2 says the series diverges if the limit is greater than 1 and if the ratio test is inconclusive if the limit is actually equal to 1. So we have a couple examples here. In exercise 1, we have the series of 2n over n factorial. And so we're going to take the limit as n approaches infinity of the n plus 1 term over the nth term. And since this is two fractions divided, we're going to multiply by the reciprocal. So we take the bottom, and here we are multiplying by the reciprocal. Let's start with the 2's. These are powers, and we're going to divide them. And when we divide powers, we subtract the exponents. So we have n plus 1 and then minus n. Well, the n's are going to cancel out, and we're just left with 2. Here it is right there. When we have n factorial over n plus 1 factorial, that's going to be here n factorial over n plus 1. We reduce that by 1 when we do factorial, so then it becomes n factorial. Those are going to cancel out. So we end up with 2 over n plus 1. As the denominator goes to infinity, this fraction will go to 0, and 0 is less than 1, so the series converges by the ratio test. In example 2, we're going to do almost the exact same thing. Here I just multiplied by the reciprocal right away. So if you put plus 1 in for this n, you get n plus 1 squared. N plus 1 in for this n, you get actually n plus 2, and 2 to the n plus 1 times the reciprocal of the nth term. So we have n minus n plus 1, that's actually 2 to the negative 1, which keeps 2 in the denominator. We have n plus 2 minus n plus 1, so the n's cancel, and then 2 minus 1 is 1, so we have 3 in the numerator. Well, with n plus 1 squared over n squared, there's not much we can do with this. But, if you think of your ending behavior for the n's here, it's just going to be the ratio of the coefficients of n squared. 3/2 is actually greater than 1, so this series diverges by the ratio test. In the third example, we have the series of n plus 1 factorial over 3 to the n. So there's n plus 1 plugged in, which is n plus 2. 3 to the n plus 1, we're multiplying by the reciprocal. This is equal to, well, let's see. Let's talk about the n, the 3's. So we have n minus 1. That leaves 3 to the negative 1, which puts 3 in the denominator. And we have n plus 2, reduce that by 1, that's n plus 1, and then we could finish it out with factorial over n plus 1 factorial. There's the n plus 2. So the n plus 1 factorials are going to cancel out. And we have the limit as n approaches infinity of n plus 2 over 3. That's just going to infinity, which is certainly greater than 1. And so this one diverges by the ratio test. I'll recall that this is a power series centered at C, where C is a constant. For a power series centered at C, precisely one of the following is true. The series converges only at C. The series converges for all of x. There exists r greater than 0, such as the series converges for the absolute value of x minus c less than r, and diverges if it's greater than r. R is called the radius of convergence of the power series. In part 1, the radius is 0, in this part right here, and in part 2, it is infinity. The corresponding domain is called the interval of convergence, and we'll look at examples of this. Find the radius of convergence and interval of convergence. Well, we have a series here, but now it involves x, and the ones before that only involved n. So we do the exact same thing. We take the limit as n approaches infinity of negative 1 to the n plus 2, x minus 5 to the n plus 1. Then we have n plus 1 and 2 to the n plus 1. Then we're going to multiply by the reciprocal of this. So we have n 2 to the n, negative 1 to the n plus 1, x minus 5 to the n. Well, what should we talk about first? Let's talk about the powers of 2. 2 to the n minus, or divided by 2 to the n plus 1, we have n minus n, and then minus 1, that puts the 2 down in the bottom. If we do the exact same thing with a negative 1, we end up with 2 minus 1, which is 1. So negative 1 to the power of 1. What else do we have? We have x minus 5 to the n plus 1 minus, or divided by x minus 5 to the n. We subtract the powers again, or the exponents, and we get x minus 5 here. And then we have n over n plus 1 left. Well, we can rearrange this a little bit. The limit as n approaches infinity of n over n plus 1 is just going to be 1 by ending behavior, and then we have negative x minus 5 over 2. So really, we do have the limit as n approaches infinity of negative x minus 5 over 2. So this thing is going to converge as long as we make this less than 1. So we have negative 1 less than negative x minus 5 over 2 less than 1. That's using absolute value. Multiply both sides by 2. Add 5 to both sides. We get 3 is less than x less than 7. So the interval of convergence is 3 to 7, and the radius of convergence is 2. We have this right here. There's 2 units. This series converges as long as x is between 3 and 7. In our next example, we have the series of x over 3 to the n. So we're going to take the n plus 1th term divided by the nth term. So we have x to the n plus 1 over 3 to the n plus 1, and then we're going to multiply by the reciprocal rather than dividing. I'm going to skip that step of division. So we have 3 to the n over x to the n. And let's see, if we subtract the exponents here, we get 1, so there's x. Subtract the exponents here, we get negative 1, which puts 3 in the denominator. Now this series will converge as long as the absolute value of x over 3 is less than 1. So we use the fact, we use absolute value, so we have negative 1 less than x over 3 less than 1. Multiply both sides, everything by 3. And the interval of convergence is negative 3 to 3, and the radius of convergence in this particular case is 3. Here's our next example. We have this quite complicated series, a lot going on here. But we're going to do the exact same thing. We're going to take the limit as n approaches infinity of negative 1 to the n plus 1. Put n plus 1 in here, you get 2n plus 3. Put n plus 1 in for this n, and you get 2n plus 3. And then we're going to multiply by the reciprocal. And there's the series repeated, but upside down. And let's see, we're going to subtract the powers here, which leaves negative 1 in the top. 3 minus 1 is going to be x squared. There's the x squared. Now on the bottom, we can write this as 2n plus 3 times 2n plus 2 times 2n plus 1 times 2n, and then all the way down to whatever n would be. And so here it is. 2n plus 3, 2n plus 2, and 2n plus 1, and then we'd finish out the factorial. So these two are going to cancel each other out, and we have negative 1x squared over 2n plus 3, 2n plus 2. Well, we can split this up, and if we use our ending behavior, this is going to 0 as the denominator goes to infinity. So we have 0 times x squared. Well, if we have 0 times x squared, it doesn't matter what x is, it will always be less than 1. So the interval of convergence is all reals, and your radius of convergence on this one is infinity. In the last example, we have n factorial x minus 3 to the n. So we're going to take n plus 1 factorial times x minus 3 to the n plus 1. There's the n plus 1th term divided by the nth term. We can subtract the exponents here. So we get, we cancel these out, and it just becomes over here x minus 3. And then we can reduce this by 1, so we can write n plus 1 reduced by 1 times n factorial over n factorial now. These two cancel out, and we're left with just n plus 1 times x minus 3. Well, this part of it is of the limit is going to infinity. So we have infinity times x minus 3. Well, now remember, it's the absolute value of this. So no matter what x is, it's going to be bigger than 1 with the exception of one value. If we could make x minus 3 equal to 0, we'd have 0 times infinity, which would be 0. And so we add 3. This will converge as long as x is 3 and nothing else. So the interval of convergence is just 3. There is no interval, it's just the number 3. And our radius of convergence, if we have really no interval, is 0.